Hello all my JavaScript friends, this is the Virtuoid, aka Mike Smith, and this is Fun with JavaScript, our cache defense game. Alright, this is our first video in talking about TDD in designing our game. So what is TDD? It stands for Test-Driven Design or Test-Driven Development, and it is a way of being able to develop your application based upon your test. Now normally you create your application and you write your test to match it. There's a lot of inherent problems with that, especially since as a developer you may know where the errors could be, so your test may not expose the errors. Well, TDD kind of helps work with that. You write a test to say, I want X to return Y, and then you write the code to satisfy the test. So you have a minimum amount of code to be able to make the test work out correctly. Eventually, the test will allow you to completely design your application, and you'll be writing the smallest amount of code that will satisfy the test. You'll have your application there, and it will be bulletproof. It will be absolutely perfect, right? Of course it will, but it will help eliminate some of the errors that you might find in regular development. So let's go ahead and get started with this particular application. Now, first of all, before I begin here, upper right-hand corner, you can go to our GitLab repository under FWJS-cache-defense. And that is a public directory. All the code I write here is always free. And since usually I record these particular videos after I've tested it to make sure I got everything correct, you can probably go to FWJS-cache-defense and see everything that I'm currently working on a little bit in the future. You can also email me at thevirtuoid@gmail.com. And as always, you can also go to funwithjavascript.com to see all of the Fun with JavaScript projects that we're working on. So with all that being said, let's get to it. So first of all, let's take a look at the directory. Now within our Cypress directory, within the E2E section, which is where all of our tests are, we currently got a whole ton of tests that Cypress put in there for us automatically. It tells us different things that we might possibly want to test for in a general web environment. Well, in this case, I'm not going to get too far worried about it. I can also get these files off of the web. So first thing I'm going to do is I'm going to delete everything that I've got underneath the E2E. And so all of my tests are going to go in the E2E. And so what we're going to do is we're going to create a game object, game test. And so let's go ahead and create a file called game.cy.js. And as you can tell there, it added the game.cy.js into our directory. So let's go ahead and now let's go to the very top of our code, which right now obviously is completely blank. And let's now start thinking about what we want to do what we want this game object to do. So our game object is going to control the game. It's going to be responsible for launching the game, coordinating all the different assets, coordinating all the different things that are happening within the game, and shutting down the game. Basically the entire life cycle of a game from when somebody first clicks on new game to when the game is over with. So one of the first things we're going to do here is let's go ahead and describe our test. And there we have it. If you're not familiar with how test languages go, this is the Chai language. You can always look it up, CHAI framework that Cypress uses. Read up on it. I'm not going to go through exactly what's happening here. This is going to basically describe a series of tests that we're going to run, and we're going to group all of our tests within this particular section here. And there we go. So we should be able to create a game object. So what we're going to do here is now let's write out our code to be able to know that we actually have a game object. And there is our code. That's it. That's all we're going to do here. All I want to do is find out, do I return a game object? That's it. I don't care about anything else. This is the first part of my design here. I don't even care what it does at this point. Okay, so let's run our test, because that's the first thing you want to do is you always want to run your test. Let's go to our command prompt. And let's type in npx cypress open. And as soon as the screen comes up here, I will browse over to that screen. Enter the magic of television. There it is. There's our screen. Welcome to Cypress. Okay, so what we're going to do is we're going to click on E2E testing. It's going to initialize the config. We're going to go to Chrome, start the E2E testing in Chrome. We're going to start that. And then what will happen is that we should now get to a test screen. Ah, there it is. Good. Okay. So we got to our test screen. And this shows you that we have run test ready to go. And that one test is our game.cy.js. So if we click on game.cy.js, it will then run the test, and it failed on the test. Let's take a look at that. And as you can tell here, the game object says, should not create an object. No commands were issued with this test, and it's given us an error at the game object itself. So, yep, there we go. We got an error. What was that error? Reference error. So of course we got the error. You know, what do we expect in that case? We hadn't written any code. So let's go back to our code, and let's actually now write a game object. Let's go into our directory, show you where to put the directory. So what we're going to do inside the directory here is we're going to create ourselves a source directory. And there it appears right underneath node modules. And then within that source directory, we're going to create a classes directory. And there you can see the classes directory. And then within the classes directory, we're going to create a JavaScript file, and we're going to call it game. And there you can see game.js. So let's now flip over to our code. Game.js is completely blank. So what are we going to type in here? Well, we're just going to try to create the class. And that's it. We've now created the class. So if we click over to game.cy.js, we now need to import that. So what we'll do is now we will add the import statement at the very beginning. And as you can tell, now the import statement is there. So if we now flip over, if we save this, and once we save it, Cypress does do a hot load, so we should now be able to go to our Cypress test screen. And yep, there it is. Expected true to be true. It's all ready to go. So that's basically, in a nutshell, test-driven development. We wrote our test, the test failed. Well, what code do we have to do to write the test? Well, that was very simple. All we had to do was just write the game.js, we just had to create it. That was it. Once we've done that, it worked. Works like a champ. So now let's start thinking about what else we need this game to do. Well, great. This game has now constructed something. What are some of the things that we do need to do to this game? Well, if you think about it, we got a game. We need to be able to create a new game. So let's create something that's called a new game. And what I'm going to do here is, let's type in this. All right, so it should start a new game. So what do we want it to do? Well, let's see. We're going to need to create the game. So constant game equals new game. All right. And then we'll call our method newGame. So we now know that we're going to probably need to create a method called newGame on game. So we've created that method there. And now we need some way to be able to know that we have a game that is now running. So what do we want to do here? Well, I think really a very easy thing to do is to have some sort of Boolean variable in which the game is, we know the game is running or not. So we're going to call that one game in progress. So we should be able to expect game.gameInProgress, spell it right, to be true. And so now we're basically saying now that misspelled game. Once we do our new game, we're now going to be able to sit there and say, okay, once new game is run, we should have a variable called game in progress set to true. Now, there is something else I want to be able to do here is that, well, we're introducing a new variable. Should we also want to test whether that variable was initialized correctly? Well, yeah, actually, I think we do. I think that would be a very good thing. So we'll add another test up here called it should set the initial parameters correct. So basically, whenever we create a new game straight out, I want to be able to basically say that we have initial parameters that have been set before, because we already now know that we're going to have a game in progress that probably needs to be set to false once that game object is created. So basically all we have to do here is say constant game equals new game. And we say expect game.gameInProgress to be false. Because when game is first created, we want game in progress to be false. And when it gets the new game method, we want it to be true. Okay, we've done our testing. We've created our new test by saying, okay, we do want our game to have ability to create a new game, and we will need to know that a new game is currently in progress. So we've now created a new method, and we've created a new property. So let's go to our Cypress, and yep, you can tell, there it is. We have errors. There they are. Da, 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 da. So our initial parameters was incorrect, and it could not start the new game because it couldn't find the new game function. So what are we going to do? Well, what we're going to do is we're going to write code to make it correct. So, well, game in progress is going to be first. So let's go ahead and do game in progress. Now, I like doing private variables for absolutely everything, and the reason why is that this allows me to be able to control the access to these two variables within a class. So I'm going to expose this as to be able to read it. Obviously, I'm going to need to because it needs to know where the game in progress is a game in progress. But I'm going to sit there and say I'm not going to have it sit there and be able to, or an application to be able to. I'm going to sit there and not. I'm going to sit there and make sure that an application does not write to game in progress. So I've got that as a private variable. So now I know I'm also going to need to basically say get game in progress, and that will return this game in progress. Okay, we also know from our test that the initial value needs to be false, so that's going to be within the constructor. So we're going to say this dot game in progress equals false. And we also now know that we're going to need a method called newGame, and newGame, I expect game in progress to change from false to true within newGame, so we now know that newGame needs to set game in progress. So let's create ourselves a method called newGame. And I know within newGame it's got to set the game in progress to true, so this dot game in progress equals true. Alrighty, so we should now have satisfied the new test here by creating our game in progress variable, by creating our newGame method, and by initializing it within the constructor. Did we actually get that everything work? Well, let's go back to our Cypress test screen and see what happened. Aha! They now all three pass. So that really is in a nutshell how you're going to test, or how you're going to write your test to be able to design your application. We started out here just having some vague ideas of what our application is going to look like. And as I'm sitting there and thinking about the test, let's get back to the code here. As I'm thinking about the game, I want the test to be able to control what the game is going to do. And so in this case, I'm saying, hey, I want to be able to create a game, and I want to have a method called newGame in which it will set a variable that tells me that a game is in progress. Now, what about all the other stuff newGame is supposed to do? Well, we'll get to that later because we'll just keep adding layer upon layer upon layer in there. And speaking of that, that's basically the next section that we want to work on here for the game, is we want to be able to kind of imagine now what are the different things that this game is going to do. Now, I have already determined, you've got to do some little bit of design, you can't, within this system here, but I've already determined that I'm going to have basically about 5 different pieces, quote unquote, to this particular game that controls 5 different areas of the game itself. And that would be basically the board, I've got some graphics. In fact, I got some graphics I'll show you up on the screen here. I've kind of done some dummy graphics I'll be using later on in the game to be able to, work with the game. But basically, the game, all I really have to worry about is I've got to worry about the board. I need to worry about my tower or the cache. I need to worry about the roads that are, that will come out onto the screen. I need to worry about the guns, the turrets, things like that, and I need to worry about my monsters. In this case, I've got a little alien guy there. So in a sense, now I'm sitting here thinking with the game. Okay, all right. So let's take this one step at a time. What's the first thing that the game needs to do? Well, it's going to need to do something with the board. It's going to have to initialize the board. It's going to have to do whatever it needs to do with the board. So let's go ahead and write a test for that. But actually, before we do that, let's go ahead and reorganize this a little bit more so we can reorganize our our game system, our game test here to be able to categorize them. You can have this, basically a describe is kind of like a grouping of different tests, and you can have describes within describes. So what I'm going to do here is I'm going to put in a new order of these particular tests here so that we can better organize our test. So I will go ahead and throw that in there, and I'll come back to you as soon as we're done. Okay, through the magic of television, we are done. In fact, since I just popped in some new code there, let's just check to make sure our tests are still passing, and they are. But notice how they're now grouped together. So I've got the two groups here, you know, one where I keep all the new game together, and another one where I keep all the creation stuff together. So no biggie there. Okay. So let me show you what I did is, like I said, you can have a describe within a describe. I've got a describe here that describes all the creation, and I put our two tests where create a game object and set the initial parameters within that. And now I've got the new game here where I have got the should start a new game. In fact, let me make sure I get that scrolled on the screen here. There we go. So I've got the it should start a new game there. But do notice I did add something a little different here. One of the things I know here, because I've done unit tests before, is that as we've grouped these things together, each one of these is going to have the exact same initialization. It's going to run or create a new game, and it's going to create a new game object, and then it's going to do the new game method. So what I've done here is I've used a routine here called before each. And what Cypress will do is that before each of these tests run, it will run this section here. So every time this test will run, it will first do this part, then do this part, and so on and so forth as I add tests here. So I just kind of want to show you that we got a little bit of extra there. And it looks like the screen was a little bit wonky there. Yeah, there we go. Okay. Better yet, so here's that before each, where each of this code is run every time it gets into a test. So on this test here, we run, before it runs this, it will run that. That way we can run common code without having to write it in each and every test. So, all right, let's get thinking about this. I'm thinking just off the top of my head here, one of the things I wanted to do with the game is I got these objects, the board itself, the cache, the roads, the turrets, and the monsters. Let's have some sort of object that represents all of those. And basically what's going to happen here is that generally I'm thinking that the game itself is going to need to communicate out to all these different objects for them to do various things or whatever they have to do. But I don't want the game specifically going and say, you know, specifically going there and giving specific monsters or specific turrets or anything like that. I want the game to be able to generically go out to each of these objects and figure out, hey, I need you to help me out here. Do what I need you to do. I need you to create this cache. I need you to create a road. I need you to create an alien. You do whatever you have to do. So what I've decided to do here is I'm going to call each of these objects controllers. So it's going to be like a board controller, a monster controller, a turret controller, a road controller, a cache controller, and so on and so forth. So let's create each of those controllers. We're going to start with the board itself, since the board is the biggest thing. So let's go ahead and write the test for the board controller. And we just typed it in there, so let's zoom to the bottom and take a look at it, and there it is. It should create a new board controller. Again, it's going to run the game, new game, and then the game.newGame there. So basically, I now know I'm going to have, it looks like some sort of object called board controller. And it looks like I just need it to be a truthy value. I don't know, because I don't know what the controller is going to be. I know it's going to be a board. I know it's going to control the board, but what it's going to do exactly, I have absolutely no clue. And I don't need to know at this point. I just need to know I need some sort of object that will in the future allow me to do things with the board from the game. So we got that board controller. So what we are going to need to do is we're going to need to also test it within the creation part of our code. So if we flip back up to the top here, let's type that in. So that's going to be expect game.boardController to be null. And so what I've done here at the test is I've said, okay, when this game is initialized, the board controller is going to be null, which means there's going to be no board controller associated with the game. So that when we actually create the game, the board controller is going to be a truthy value. So that should be it in that particular case. Let's flip back over to, whoops. That should be it in this particular case. So let's flip over to our test. And yep, our tests have failed. Oops. Our tests have failed. There's the failure because undefined is equal to null because it's not undefined, and false would be equal to true because, hey, it's undefined. All right, well, so what are we going to do about that? Well, we are going to add it. So let's add it to the game. So the first thing I added here is I've added the board controller as a private variable. Now we need to initialize it within the constructor, and I'm going to initialize it to null. Why? Because the test says that when the board controller is initialized, it is going to have to be null, period. And oh, that's right. Yeah, I was about to say, why is it still doing an underline? Because I haven't got that far yet. Okay, that's right. So I know that board controller is going to be null. Since this is a private variable, I'm going to need to get a getter function for the board controller. So let's pop in that getter function. There's the getter function. And now within the new game, what are we going to do within that new game? So let's go to that code on the new game and let's insert the code for the controller. Because this is something that's very important that I want you to understand about test-driven development. Well, there it is. That's our board controller. I know what you're saying. It does absolutely nothing. What about the board object? And what's the board object actually going to be doing? Is it going to be responsible for drawing out the scenes? Is it going to be responsible for controlling, you know, for sending messages out to the cache or to the aliens? I don't know. That doesn't matter right now. All that matters is I have some sort of board controller. It's going to do something in the future. Now, probably once we fix this, in fact, I guarantee you, once we fix this, we're then going to go to the board and start saying, okay, what do I want the board to do? So the idea behind this test-driven development and test-driven design, the TDD, is that we're using the test to drive our design. At this point, all I'm caring about is the game. I don't care about the board controller. I just know I'm going to need one. So I'm just setting it to something that is not null, because that's what the game says it's going to have to be. Basically, expect it to be truthy. And that will also allow me that once I do actually have a board controller class, this will still succeed, because at that point, you know, the board, you know, all I care about was whether it's falsy or truthy, and when it's null, it's falsy. So that should be all we need to do there. Once we have saved it, let's go over to our test. And wow, did you see that? They're all passed now. So that's really all there is to that, the board controller. So we've got that. What are the other objects we're thinking that we're going to need? Well, let's think about this for a second. We had the board. What was the other one? Yeah, cache, the cache, our tower. We need to do that too. So let's throw in those tests for the cache. Okay, so our cache controller is in. We're going to expect our game cache controller to be null because it's working just like the board controller. And we should be able to create a cache controller, and it should be a truthy value. Did we succeed? Of course not. We did not succeed. Why did we not succeed? We didn't succeed because we haven't defined the code. Remember, you write the test, it fails, then you write the code, and it succeeds. So let's write the code. Okay, so we've got the cache controller in there. Very simple. Just like with the board controller, we created our private variable. We have initially set it to null. We have gotten our, let me roll down, scroll down here. Yep, we've got our get cache controller all rip roaring ready to go, our read-only, you know, getter function. And then we've set it to set cache controller. Because again, I don't know what the cache is supposed to do right at this point. I just know I got to have one. That's all it really is to it. So that's it. Did we pass? Yep, we sure did. So let's go to the next one. We did the board, we did the cache. Now let's do the road. In fact, what we're going to do here is, just for sake of time, since now you know kind of what I'm doing here, we've got the other three objects. We're going to need some sort of road controller to control the roads. We're going to need a turret controller to do the turrets, and we've got some sort of monster controller to do the monsters. In fact, the turret one, I've been calling it turret here because that's the only picture I got there. In actuality, I'm going to call it the armory, because eventually, once we get everything working, we'll add different types of gunnery. So we're doing an armory here. So what I'm going to do here is I'm going to very quickly pop in the rest of the code for the testing. And let's, flip over to the testing. We're going to pop in the rest of the code for the testing, and I will see you as soon as that's done. Okay, we're all done, and as you can tell here, there's my road controller, arsenal controller, and monster controller, and the IDE is showing me errors because I haven't created the code yet. And consequently, if we zoom into the bottom, there's our road controller test, our arsenal controller test, and our monster controller test. So obviously, if we go to our test, we got now a whole bunches of errors. We got 4 different errors there. It's just saying, nope, I can't do that, can't do that, can't do that, can't do that, can't do any of this. You're messing me up here. So let's go back, and now let's add the code into our game object. Okay, and through the magic of television, we are here. As you can tell, we've added our 3 private variables. Again, just like the board controller and the CacheController, we got the road, the arsenal, and the monster controller. We have initialized all 3 of them to null. Let's see if we can get all 3 of those on the screen here. Well, we almost did. We came very close. So we got the road controller getter function, the arsenal controller getter function, and the monster controller getter function. And so all we really have to do now is take a look at our code for the new game, and we did the exact same thing here that we did with the board and cache for the road, arsenal, and monster controllers, in that we're basically, again, setting it just to any value that is not null, because we have absolutely no clue what the road, the arsenal, or the monster controller is going to do. So now that we've saved all that, let's go to our test screen. Ha! It's still there. Everything is still working great. So we're now green. So last thing I want to do here on the new games, I've got all the controllers. I know for a fact I'm going to need some sort of round counter, that will keep track of the rounds. So let's add that in. Let's go back to our code. Let's add the test in. So what should the test look like for this round controller? Well, that's a very, very easy one. Let's pop that in there. Let me go to the bottom of the screen. And there it is. We should set the round number to 0. So we should expect game.round to equal to 0, which basically means that this round that we have should basically start at 0 once the new game has been created. So what value are we going to put it to before it gets to 0? So what I've decided to do, before it gets a new game, what I've decided to do is I am going, let's bring up that code here. What I've decided to do for the round, and let me bring it up on the screen. Whoop, there we go. What I decided to do on the round is to basically set it to null. And that's really all there is to that. That's it. There is nothing else there. So again, that should automatically fail. Sure enough, it does. There's the 2 failures. So let's now go back into our game code, and let's add the round in. Alrighty, get through the magic of television. There's my private variable. We are setting it to null to begin with. Let's zoom to the bottom of the screen here. And there's our round. I will bring both of these at the same time here. Here's where our getter function is, and here's where we set it to 0 when the new game is set. And that should now satisfy the test that we have created earlier. So let's go back to our test screen, and binga banga bonga, there it is. It's done. That's it. So with this gives you a very good overview of how the TDD is going to work. And I really kind of went into detail, a great deal of detail with this one, exactly how it works. Because when we start doing the board and the cache and the road, the arsenal, the monster, I'm going to zip through it a whole lot faster. But I really wanted to spend the time in this one to kind of show you exactly how it works. So I now have, let's go back to the code. I now have within the test an entire suite of tests here. It does everything I want to do. I want it to be able to create a game object. I want it to be able to test to make sure that all the variables are set initially to their quote-unquote null values. And then once they get set by the newGame, which we'll scroll down here, once they get set by the newGame, I want them to be able to test to make sure that we have active instances of our board controller, our cache controller, row controller, arsenal controller, monster controller, that our game in progress has been set to true, and that at the very bottom here, our round number has been set to 0 because we haven't really started a round at that particular point in time. And because I've set up my test first, I have now written in here the absolute minimum amount of code necessary to get all of that done. As you can tell here, man, that's it. There's no fluff, no muff. I haven't gone ahead and within the game and defined exactly what all the controllers do or do anything that was weird about the game in progress or anything like that. I've written the absolute minimum to get the test to succeed. So my code is as small and as sharp as possible. Is it bug-free? No. Could it probably be a refactor? Possibly. Especially once we start getting these controllers in, maybe a little bit of refactoring, but that's okay. No problem there. But that's basically it. Well, that's not even basically it. That is it. That's what test-driven development does for us, and test-driven design. We use our test to design our games. And in this way, our games should be very small, have a small footprint. They should be very concise, assuming our tests do exactly what they need to do. It should be very concise, and it should be able to give us everything we want without a whole lot of fluff. Our next video will start covering the board controller. Thank you very much for watching. If you like this video, please click on the like button below. If you wish to keep informed about new content, click on the subscribe button. And as always, please leave a comment below. I'd love to hear from you. Again, thank you very much for watching. This is the Virtuoid, aka Mike Smith. We'll see you later.